Now, our next session is also pretty inspiring. It's a pre-recorded a keynote, but from someone who is extremely charismatic, Dr. Tim Chow. Now, there won't be questions following this session. However, Tim is easily found on right across social media. You'll find him just about everywhere, and he's really, really great at answering people's questions. And Dr. Tim, for those of you who don't know, his full bio is online along with all of our speakers. He sits on a number of boards. He's a lecturer on cloud computing and was previously president at Oracle On Demand. So over now to Tim.
Good morning, good afternoon. Thank you for having me. I'm here to talk about what I think is perhaps the silver lining of the current COVID crisis. I'm going to talk a little bit about technology, give you some insights into 5 key technologies, talk about those implications to some industries that you may not be aware of, by talking about why this might change how the buildings of the future, how the cities of the future might look. And then I'm going to conclude with a project that we've been working on for the past year, a moonshot mission to connect all million healthcare machines in all the children's hospitals in the world. But before I get started, let me introduce myself. My name is Tim Chow. I have had a long career in enterprise software. I served as the first president of Oracle's cloud computing business. After I left there, I actually returned to Stanford University to start the first class on cloud computing there. And it's actually there where this story begins. I had the pleasure of having Bill Rue, while he was serving as the CEO of GE Digital, come to my class, and that kind of began a long-term relationship with Bill that, you know, we still chat and see each other today. And thank you, Bill, for inviting me to be a part of this meeting. Anyway, I'm hoping to teach you a lot of lessons for long life in your career, but I'll start with something perhaps more important, which is lessons for long life in your personal life. This image, this calligraphy is actually taken from a temple in Kyoto, Japan. It's believed to be over 500 years old. It literally contains the 10 secrets to long life. So I'll wait for you to copy it down. Okay, for those of you who are not reading or writing Chinese yet, here's the translation. You're supposed to have more vegetables and less meat, more anger, more laughter and less anger. And then the one that I find personally amusing, the more bathing, less clothing. So you have to think that Buddhist monks 500 years ago didn't have Netflix, so maybe this was the entertainment for the day. So as we started this conversation, we started with COVID, and it's not been a great thing. This photo is actually taken from last year in Silicon Valley, where I live. We had a really terrible day where there were fires actually surrounding the Bay Area. It turned the whole sky orange. It really looked like the zombie apocalypse. Plus, we were all in lockdown from the COVID. So what are the silver linings to this? Well, I think for many of us, the shift in how we worked from, going into the office, commuting all day, to being able to work from the home, not only gave people more time with their families, but it actually, and I'm serving on the board of a company called Blackbaud, we've actually seen that we're seeing people working an hour extra a day. So it's increasing productivity as well as increasing time with your family. For those of you who've seen Raya, the Last Dragon, I encourage you to look at some of the short videos they produced with it on the Disney Channel. Raya was actually made all during the time of COVID. And if you think about this, it's a highly collaborative, illustrators, animators, voiceovers, everything together, typically in one room, but they did it all from their homes. And so how is that all possible? Well, it's all possible because of advances, particularly in networking technologies. But also in what I think of as 5 key technologies for the next decade. So let me start with number 1, which is cloud computing. You probably have heard about this over and over again, but you know what Amazon, AWS, Microsoft's Azure, Google's GCP all do is in essence provide compute and storage that they manage the security, the availability, the performance of that, deliver it in an OpEx model, and house it in about 10 data centers in the world. The economic advantage of this model is huge. Just to give you an example of it, today you can acquire 1,000 computers, 1,000 servers for an hour for $25. 1,000 servers for an hour for $25. It's enabled a whole new class of applications. I'll talk about some of that later, but just remember the economic advantage is where this technology has made a huge leap. Next, 5G. Again, you probably can't avoid hearing about 5G. Every cellular provider is talking about it. Let me highlight 3 essential things that 5G brings to us. First, higher bandwidth, very well aware of that. Lower latency, what does that mean? That means faster response times, being able to talk to a server and return back in less time is a feature of 5G. And lastly, the ability to connect a lot more devices from any one tower. So 5G is spec'd for being able to connect about 1 million devices per square kilometer. So I was kind of curious, well, is 1 million a little or 1 million a lot? And I did a talk a couple of months ago where I spent a little research time. So I was like, well, where's the densest population in the world? Well, it turns out, and some of you may already know this, it's Mumbai. Mumbai has 30,000 people per square kilometer. So 30,000 people per square kilometer. Well, let's assume everybody's got 2 cell phones. That's 60,000 devices. Well, they just spec'd it for 1 million. So what is all the other things that are going to be connected? And so that brings us to the third major technology, the so-called Internet of Things. Here, I'll point out to you something that in the world today, there are about 600 billion things, 600 billion machines, compressors, cars, MRI scanners, tractors, mining machines. 600 billion, there's only 6 billion humans. So that's literally 100 times the number of machines, things than people. Now, most of the technology that we have developed up until now has been for what I like to call the Internet of People, meaning that we think that at the other end is a human typing on a keyboard or mousing around, but things are not people and people are not things. So why would the technology that we develop for the Internet of People work for the Internet of Things? And I think there's a whole new types and kinds of technologies that are going to be developed for the Internet of Things. So that brings us to the fourth major technology, edge computing. In tech, we've always gone back and forth between centralized and decentralized computing. We are currently in a heavily centralized view of the world, meaning let's move all to the cloud, move to Amazon, move to Azure, which is all, as I said, great for a lot of different reasons. But I made a point to you that those servers are in about 10 data centers in the world. And there are a whole set of applications for which it's not going to work to come out of just a few data centers. So network latency, some applications require very fast response times, and it's not possible to go from your car in Palo Alto out to Reston, Virginia to that data center and come back again in any time that would be meaningful. So low network latency. Number two, applications which have a lot of data. Just to give you a sense of this, in the pediatric cardiology Echo unit at Stanford, they generate about 50 gigabytes of data per day, 50 gig of data per day. Now, if you think about what it would cost to transmit all that data to a center cloud and get it back again, well, that's pretty expensive. Third kind of application that's going to have difficulty is ones which require a greater degree of autonomy. So where the network connections may not be very reliable going out to a center cloud, just imagine being out on an oil drilling rig is a case of that. And last, applications which require greater degrees of security, privacy, and compliance. Again, I'll point at healthcare where there's a great deal of sensitivity to whether or not I'm going to let that CT scan, that MRI scan leave the building. So for all those reasons, edge computing is going to be a major thing that will happen. I'll show you an example of some work we're doing at the very end of this, but it will be the fourth major thing. And so that brings us to the fifth. And again, you may have heard a lot about artificial intelligence and the whole debate about whether or not it's going to take over all of our jobs. I won't go to that question, but let me tell you that the technology is advanced at meteoric rates. Just to give you an example of this, there was a competition set up at Stanford at the beginning of the 2010s, at the beginning of the last decade, to basically compete humans against computers as to who could recognize an image better or more accurately. Turns out at the beginning of this competition, the computers were only good 75%. Humans were 95% accurate. About 7 years later, the computers actually built the humans. And as you can imagine, the competition doesn't occur anymore. And it's in this last decade that we've seen all these advances. Why? It's centrally because of a technology referred to as neural networking. There's a wonderful slide that Jeff Dean put together many years ago. He heads up Google Brain. And basically it says, with neural networks, we are able to, with increasing amounts of data and increasing compute, remember I said how low cost computing is getting, I can get increasing degrees of accuracy. So just check out Facebook's facial recognition. Why does that work so well? Well, they have a ton of face data, right? In any case, right, the ability to aggregate large amounts of data with large amounts of compute, I can get increasing degrees of accuracy. So what's the implication of all this cool technology on industries, on businesses, on the enterprise? I'm going to take you through a few examples. I'm going to start with mining. Here's an area that you probably never thought much about. I know many of you are aware of autonomous driving of automobiles, but this is actually a screenshot of a video. Just go check out Sandvik, glass, autonomous mining on YouTube, and you'll pick it up. It actually shows a maze they built out of glass in a giant warehouse. They take this mining machine, which is driven autonomously, and it drives literally through this glass maze without breaking a single pane. In the middle of the video, they stop the machine. A guy gets on, takes over the controls of the machine, and basically shatters all the glass in this warehouse. It looked like something could have been fun to do. At the end, the guy gets out. He's actually the CEO of Sandvik, so I'm sure they had a lot of volunteers for doing that job. So autonomy is not only being applied to ideas about autonomous driving of personal cars, but also to areas like mining and construction and places where mobile vehicles do exist. Which brings us to the world of agriculture. Actually, in many ways, agriculture has had autonomous driving for a long time because it's a far simpler job, because in a field, you can block everything out. There's no kids running across a street or anything like that. So autonomous driving in high-end tractors has been going on for several years. But I want to point out a slightly different point with agriculture. One of the things that the ability to connect to machines, aggregate data in the cloud, and be able to run algorithms is you can operate with greater degrees of precision. So what is the meaning of that in agriculture? Well, hey, I can use less pesticides if I know exactly where to spray, less herbicides. I can use less fertilizer, again, because I know exactly where to go put the fertilizer. I can operate with greater degrees of precision. The implication of my business is I can reduce my operational costs, which in many businesses, including airlines, the consumables cost is the dominant cost of my business. So I can make more money as a farmer, but the other thing to think about is if I use less herbicides, less pesticides, I'm actually creating a healthier product. So many examples I know of all this technology seem to apply just to, let's call it, first world economies. And I want to highlight really how to think about this in other economies. I'm going to talk about Vietnam. I authored a book called Precision a few years ago. It's actually been translated and published in China, Korea, and India, and lastly, in Vietnam. So I was invited to kick off the book in Vietnam. And at the end of my tour, I was actually presented with a 5-year citizenship to the country of Vietnam. Now, you could ask, well, why? How did that happen? Turns out very early in my visit, I had lunch with a senior official in the government. And we're talking over lunch. And I said at the end of it, by what I've learned from you, I think there's things that we can do in technology which would transform your economy. And let me give you a couple of examples. So I started with street sweepers. It turns out in Hanoi, they had bought a whole bunch of street sweepers. And I said, look, you could take those street sweepers, you could connect to them, you could collect the data from them. You could use that data to optimize the operations, optimize the maintenance, et cetera, of those street sweepers. And by the way, I'm pretty sure you could sell that software to the street sweeping company or maybe to other people who have street sweepers. So street sweeping seems kind of incidental. So I went and moved on to a big industry for them, which is shrimp farming. It turns out Vietnam is the largest supplier of shrimp in the world. So you look at that and you say, well, if I'm in the shrimp business, what's the next logical step? Well, the next logical step is premium shrimp. And how would shrimp become premium? Well, it would be because you control the quality of that shrimp. How would you do that? Well, you do a lot of work in, well, what were the nutrients in the water? What were you feeding the fish? How do you process the shrimp, et cetera? How could you do that? Well, I just talked about how you could connect machines, learn on this data, be able to do things completely differently. So finally, let's talk about textiles. Many textile manufacturers have moved out of China into Vietnam because actually the cost of labor is lower in Vietnam than in China. So I told him, I said, well, my guess is you walk in any of those textile manufacturing plants, you're not going to see machines that are doing this manufactured by somebody in Vietnam. I said, you guys know more about textile manufacturing than anybody in the world today. Why would you not build a next generation connected, smart textile machine, which not only could revolutionize your industry, but also you could export those on a global basis? So those are just a few examples. I know you guys are in building buildings, building cities, et cetera. So let me talk a little bit about new technologies that could transform our buildings of the future. And I'm going to give you a couple of examples out of Silicon Valley where I live. So I'm pretty sure you all, with every building you build, it's wired, it has electrical wiring, it's wired for power, it's wired for water, it's wired for sewage, et cetera. What it is typically not wired for is a network. And we've all experienced it, whether it's in a home, whether it's in a building, how poor network connectivity can be as you move around a space. yeah, it's great in the bedroom, but not great in the living room. This photo you're seeing here is actual taking a picture of a area in India, or a condo in India, showing just how bad in some areas of that condo the network connectivity is. Yes, there's technology out there like 5G and mesh networks and whatnot to go do this, but 5G is going to take a while to get deployed because it requires lots of antennas, and there are many objections by people to those antennas. Mesh networks tend to be fairly expensive, and just my point, it makes you, the consumer, the user, the building owner, have to deal with this. Why not build the network into the building? And this is a young company called SIF. They've actually engineered a technology which will allow your electrical cable that you already spent the time and money to install become the network backbone for the building. And you're actually using the power plugs, the switches, as the locations of the antennas. So you can imagine now you could build the entire building, and on day one, it has a fully functioning last meter network inside it. I think that's the future of buildings, clearly. So what could you do with that if you had ubiquitous connection? Well, the next one I want to talk about is, what if you had buildings or areas that could see? Camera technology has gotten very, very cheap. And we're aware of a project you guys have worked on in Melbourne and just played around. Here's a slide just to show you, with an idea that said, well, what if there were 1,000 cameras in that space? What could I do with that? What could I do with safety, with making people's lives easier by, scheduling the elevator before you even arrive to the elevator, et cetera? All of this is doable with the technologies we have today in 5G, in cloud computing, et cetera. So I'm going to end with a project that we started about a year ago. What's a silver lining of COVID? Well, a lot of my friends in technology, we have lots of time to think about ideas and increasing amount of times to work on them. So we launched a company. It's called Bevel Cloud. With a moonshot mission. And what is that moonshot mission? The moonshot mission is to create an environment, a platform to enable applications to share data from over 1 million healthcare machines in all 500 children's hospitals in the world. Fundamentally, a digital infrastructure that could transform children's healthcare. So let me just bring it all together for you with a simple example. It turns out pneumonia is the #1 killer of kids in Africa. And it's not because there's not low-cost scanner technology. There's just no one to read the scan. There's a single pediatric cardiologist in the country of Rwanda. And by the way, I'm not sure that the country of Rwanda is too dissimilar to rural Australia or rural America in the density of pediatric cardiologists. So let's assume that we thought, which is important, that we are able to do pneumonia diagnosis. Well, how would we do this? Well, I just told you about AI technology. What if I could aggregate all the data from all the scans of all the kids in Africa, their CT scan, their ultrasound scans, et cetera? What if I could compute on that at the edge and be able to create models which allowed me, without having to transmit any data, that would allow me to create models to diagnose pneumonia? And furthermore, what if I could take that and put that pneumonia diagnostic literally on every scanner in the world? So we are building what we refer to as an edge cloud. A simple way to think about it is, today I said the center cloud exists in 10 buildings in the world. We can put a edge cloud in any building in the world. And that ability to do that, I believe, will transform many industries, including the world of healthcare. So I'll end by talking about the last thing to get you guys thinking about, whether it's you or your kids, which is, what about our planet as a whole? There are people I know who are working on moving us to Mars and whatnot, but I think for the foreseeable future, we're all going to be living here. And there's an increasing population across the world, less resources. So we are going to have to operate much more precisely than we did in the past. And so the technologies I've talked to you about, I encourage you to become students of that, encourage your kids to become students of that, so that you can now apply this, whether that's to the world of healthcare, as I just talked about, or the world of textile manufacturing or mining or agriculture or transportation or any of the fundamental infrastructures that run the planet. Thank you for taking the time. I hope you all get interested in the subject and become students of it and help make the world a better place for us and for our kids. Thank you. Thanks, Dr. Tim Chow. He certainly does inspire us to do that, just that. And he also makes it all seem so simple and straightforward. Fantastic presentation. As I said, Tim isn't available for live questions immediately, but he is very accessible right across social media. You'll find him, and he's terrific at getting back and answering questions.